everyone. My name is Luyao. I'm from Nanyang Technological University. Today, I'm going to introduce our research paper accepted by ACL 2023, which is named PAD Zero-Shot Persona Attribute Extraction in Dialogues. Persona usually describes a user's attributes, such as the occupation, preference, family, and education background. Persona attribute extraction in dialogues is a crucial task for persona-based dialogue systems. It is to extract persona attribute information from conversations in the form of subject, object, and relation triplets. Here we use PAD for simplicity to represent the task persona attribute extraction in dialogues. Here's a conversation snippet. The girl has a persona. I have one cat, and I dislike dogs. As the man asks, how do you spend your weekend? The girl may say, I usually play with my cat. Then the persona attribute extractor is trained to extract the triplet, I have pet cat. However, the existing dataset usually provides wrong triplet annotations for such cases, like I have one cat and I dislike dogs. This is because during the data construction, the ground truth labels for the given persona is I have one cat and I dislike dogs, and the previous method simply assigned the two triplets to the current attribute as the triplet labels. Since the attribute is recognized to be entailed with the given persona through natural language inference techniques. However, I dislike dogs is the external information and cannot be reflected by the attributes, which is inconsistent with I usually play with my cat, and the relation have is less specific than the relation have pet. Therefore, we propose a semi-automatic annotation method to rebuild a dataset for pet tasks with both specific and consistent labels. Our new dataset is named Persona X. As is shown, our dataset has relatively more relation types than RT datasets, few real, but much less entities than few real. Here, RT is short for relation triplet extraction. This means the subject-object pair in pet task can be connected by more relation types than that in RT task. Here's an example. At first glance, persona attribute extraction is quite similar to RT task. Given a sentence from a document Eiffel Tower is located in France, RTE is to extract the Eiffel Tower as the subject, France as the object, and located in as the relation. We did the same thing in pet task. However, the main difference is that there are usually more than one relation types between the subject and the object in a dialogue utterance. For example, the relation type between I and father can be live with, raised by, and get along. We can easily change the relation type by flipping one or two tokens in the utterance, such as like to hate. This leads to hard sample problems, where utterances with similar token distributions may convey different relation types. Therefore, we propose a hard negative sampling strategy, meta-V sampler, and contrastive structures constraint to deal with the hard negative sampling problem. The main idea of the meta-V sampler is that we use the latent variables Z generated by meta-V to represent the distributions of utterances with different relation types. Then the relation distance between the latent variables Zi and Zj can be used to measure the probability between the utterances and their relation types Ri and Rj. This can help us to retrieve the adjacencies closest to the given adjacencies in terms of relation types. These adjacencies are considered the hard negative samples for the given adjacency. After that, we use the contrastive structured constraint named CSC to disperse the given adjacencies and the hard negative samples. This is the overall framework of our meta-V sampler with CSC. As mentioned, given the adjacencies, I enjoy playing with cats. With relation type like animal, meta-V sampler retrieves the adjacencies that are closest to the given adjacency in terms of relation distance. Then the persona attribute extractor are trained to disperse the adjacencies together with the negative samples and predict the target triplet labels. Meanwhile, the meta-V is also fine-tuned with the next word prediction objective and update weights for meta-V sampling. The experimental results suggest that our PAD framework outperformed the strongest baseline in most indices, and our meta-V sampler with CSC showed better performance than other negative sampling strategies. In the figures, there are three groups in three different colors. In each group, there is one positive sample and three negative samples. And we can see that before applying meta-V sampler and CSC mechanism, the positive sample and negative samples are closely located within each group. This makes it difficult to differentiate the positive and negative ones. After that, in each group, the positive and negative samples are relocated in the vector space and far from each other. That's all. Thank you.